Hi guys, it's Emily with the National Museum of Nuclear Science, and today I will be showing you how to make your own red cabbage indicator and explaining to you how that works. Let's get started. So first we're going to make ourselves some red cabbage juice by simply cutting up a red cabbage, blending it with water, and then straining this to remove the extra pulp. And now we're going to test it in many different solutions, one of which is gelatin, which happens to be jello, which happens to be delicious. So what I'm going to do is I'm going to add the red cabbage juice to each of these different items. So first vinegar, and in vinegar it turns pink. Next Sprite, which is a soda, which turns pink again. Next lemon juice. And next tap water, in which it remains purple. Next gelatin, which also turns purple. And soapy water, and remains purple in this as well. Next, baking soda, in which it turns blue. And lastly, bleach. And in bleach, the red cabbage juice turns a yellowish color. So, why does this happen? The reason that this happens is that red cabbage juice is a natural pH indicator, meaning that it changes different colors depending on whether it is in basic, neutral, or acidic conditions. So, what do I mean by an acid? What do I mean by a base? And what is pH? So, this all comes back to water. So what water does is it dissociates into a hydroxide ion into an H+ ion. And this is important. So water, when it's pure water, will have an equal concentration of H+ and hydroxide ions in solution, and this is what we call neutral. In something that is acidic, there's going to be a greater amount of H+ ions in solution. And in something that is basic, there is going to be a greater amount of hydroxide ions. So we can look at this on the pH scale, which stands for potential hydrogen. And a pH scale is numbered from 1 to 14, with 7 being neutral, and 1 to 7 being acidic, and 7 to 14 being basic. Remember that something that is neutral has an equal concentration of hydroxide and H+ ions. Something that is acidic has a greater concentration of H+, and something that is basic has a greater concentration of hydroxide ions. So why does red cabbage juice change color at these different pHs? So this can be explained by the anthocyanin molecule present in red cabbage. So in acidic conditions, which are pink, the extra H+ ions will migrate and bond to this molecule, and this causes the pink color. In basic conditions, in which there's excess hydroxide, the H+ ions will detach, and this is what causes the blue or even yellow color to happen. So this anthocyanin molecule is not only present in red cabbage, but it is also present in many fruits and vegetables as well as leaves, and it can explain why fruits change color when they ripen, as well as why leaves change color in the fall.